This is a project overview for our ECE 471 Embedded Systems final project. Our project was to create a Bluetooth mouse utilizing a resistive touchscreen. The project members are Jonathon Murphy and Brandon Furge. For components, we're using SCI to communicate to the Bluetooth module. For an external trigger, using a push button. For the I/O, we're using a digitizer. For analog and digital conversion, we're using the digitizer and the potentiometer. For a brief overview of our project, we're using a resistive LCD touchscreen as a trackpad. We're using a Bluetooth module that has a built-in human interface device profile. This is used to communicate between the microcontroller and the host computer through a USB dongle. We're also using a push button to initiate connection or terminate a Bluetooth connection, and the potentiometer to scale up or scale down the X and Y values. A brief overview of the technologies involved. We're using a resistive touchscreen digitizer. To use the digitizer, you have to ground one side of the sensing bars and drive the side that's opposite this bar. This creates a potential difference across the resistive layer. There's a second resistive layer that has bars on either side of the screen perpendicular to the original set of bars. Either of these bars can be used to sense the potential difference between the resistive layers when the screen is touched. By using analog to digital conversion, we can take this relative voltage and convert it into an integer that we can use within our program to determine where the screen was touched, and translate that into a relative position that we can use to send a command to the host computer. The human interface device profile was originally created for USB applications to easily interface devices with a computer. By adhering to the human interface device profile, the necessity for a driver is eliminated. To use the human interface device profile, you must first identify the device that is connected to the host computer, and then follow the report format for the device that was selected. For our application, we are using a mouse raw report format, which consists of a start byte telling the computer that we're using a raw report format. The next byte tells how many bytes will follow this initial instruction. The byte following that is a device identifier, which tells the computer that this is a mouse. And the next 4 bytes give descriptions for the buttons that are currently being pressed, the relative X position that was moved for this clock cycle, the relative Y position that was moved for this clock cycle, and the state of the mouse wheel. Utilizing these technologies described, we were able to create a wireless touchpad mouse which sends instructions through the Bluetooth connection to a host computer. When the device is initially powered, it will attempt to make a Bluetooth connection with the last device which it was paired with. If a connection cannot be made, pressing the push button will trigger an interrupt which will reset the SCI communication with the embedded Bluetooth module, and then try to establish a Bluetooth connection with the most recently paired computer. If a connection has already been made, pressing the push button will also terminate this connection. Once a connection has been made, our program will continuously loop to pull the resistive touchscreen to check for a press. If a stylus is touched to the screen, arrays will be populated with recent relative movements across this screen, which can be translated into instructions to the host computer. These movements can be scaled through the use of a potentiometer. The potentiometer is also wired into an analog to digital conversion channel, which we use to multiply the value of the relative movement to give us a scaled result. The higher the potentiometer value, the further the mouse will move with a relative movement on our resistive touchscreen. In addition, we have also programmed logic which will track the stylus if it remains still. If the stylus remains still for an extended period of time, a left mouse click will be sent to the host computer. If the stylus stays still for a longer period of time without being removed from the screen, a right mouse click will be sent to the computer. It is important to note that these controls are not sent until the stylus has been removed from the screen. This eliminates confusion and allows us to accurately determine whether a left mouse click or a right mouse click was desired. after the mouse click was sent. These conditions are zeroed out, and the resistive touchscreen is once again used to track the relative mouse movement.